September 22, 2017. Researchers from the People's Friendship University of Russia RUDN University have studied the mechanism of drug resistance for ovarian and breast cancer cells. They discovered that these cancer cells have redox-dependent mechanism which is tasked with sustaining their drug resistance. The results have been published in 2 articles in the Journal of Free Radical Biology and Medicine. Researchers from the RUDN University have found out one of reasons why chemotherapy, in particular, cisplatin, gradually stops affecting the cells of ovarian and breast tumors. The authors study the biochemical mechanisms which allow tumor cells to develop resistance to anti-tumor drugs. During chemotherapy, when using certain drugs, the tumor cells are affected by toxic and oxidative stress, which stop their functioning. Sometime later, however, the cells get used to the drug action, which necessitates using stronger doses of the drug, which, in turn, negatively affects the patient's organism due to its toxic effect. To stop the development of drug resistance, researchers need to learn operating the expression, the process of transferring hereditary information from DNA of genes that control the cell viability. Many mechanisms allow it, including the redox processes which regulate, in particular, the cell antioxidant defense, which protects the cell against oxidative stress so that it could function properly. Without those defender genes, it would be far easier for drugs to kill cancer cells. The researchers hope that the process could eventually be controlled. Some of these genes' expression changes happen when human ovarian cancer SKOV3 cells and human breast cancer MCF7 cells develop resistance to an anti-tumor drug, cisplatin. Anti-tumor action of cisplatin is achieved in no small part by its Prooxidine effect, meaning that it uses oxidative stress to destroy cells. As a result of development of the drug resistance in cancer cells, it was observed an increase in the gene expression encoding isoforms of thioredoxin and peroxyredoxin, which play an important role in the antioxidant defense system and the redox-dependent signaling. Significant increase in expression of such genes substantially contributes to forming a high level of antioxidant defense under development of cancer cell resistance to Prooxidine action of cisplatin. Thus, the growth of expression of the PRX6 gene was observed in the resistant cells. The data obtained also points to a significant role of PRX1, PRX2 and PRX3 isoforms in the redox-dependent mechanisms of the resistance development of the cell lines. Elena Kalinina, one of the article's authors, DSc. Professor of T.T. Berezov Department of Biochemistry RUDN University Institute of Medicine, told us. The increase in gene expression points to the fact that isoforms of thioredoxin and peroxyredoxin participate in the development of cancer cell drug resistance. The researchers note that this effect can also be considered as a part of a redox-dependent adaptive antioxidant response to the oxidative stress caused by cisplatin's Prooxidine action. The results obtained significantly expand our fundamental knowledge of the sum total of molecular events in the mechanisms of death and formation of drug resistance for cancer cells, and of the role redox-dependent systems in these processes, Elena Kalinina concluded. These results, obtained by the researchers, in the future, will enable us to improve the drug treatment programs for oncology patients. RUDN University. We have handpicked the best science podcasts for 2017. Sit back and enjoy news science podcasts updated daily from your favorite science news services and scientists. Now playing Radiolab. Oliver Sipple. One morning, Oliver Sipple went out for a walk. A couple hours later, to his own surprise, he saved the life of the President of the United States. But in the days that followed, Sipple's split-second act of heroism turned into a rationale for making his personal life into political opportunity. What happens next makes us wonder what a moment, or a movement, or a whole society can demand of one person. And how much is too much? Your browser does not support the audio element. Now playing TED Radio. Our future consequences, from data collection to gene editing to AI. What we once considered science fiction is now becoming reality. This hour, TED speakers explore the future consequences of our present actions. Guests include designer Anab Jain, futurist Juan Enriquez, biologist Paul Knopfler, and neuroscientist and philosopher Sam Harris. Your browser does not support the audio element.